So Eliot, I tried to find the video. I had the still of it up there. So Eliot with Cinetel, it was Cinetel, right? Or
way back when, yeah.
So Eliot was on a show called Inside the Black Box, and I think we did that maybe 15 years ago, maybe more.
Got to be that. It's a long time ago.
doing camera tracking, and all of it has evolved to Jetset Pro, and we're super excited to have you on the show, Eliot. Good to have you back.
It's great to be here. It's kind of a fun circle of life sort of thing, because I was in the inaugural 2001 era Pixel Core Online group. Yeah, and that was my start in the visual effects world.
Oh, really? And that was when it began?
That's where it began. It started from me trying to make a short film and just. Failing, if there's a Kelvin scale of bad, wow. And it shocked me, frankly, how difficult it was to make anything good, right. And so, going through understanding the difficulty of putting together a production and thinking, oh, I've got the idea. I'm going to separate the background problem from the foreground problem. We'll just do the visual effects for the background. Right. And that led me, to that first batch in Pixel Core. And that you had put together, and so it was fantastic. I learned this enormous amount, but I also learned the things that were the killers in all this, and that's what started the journey.
And because where did you come before you did the first camera tracking? What were you doing before then?
Robots. I crashed cars for graduate school and doing crash test analysis, and then started building robots. So I was the original lead mechanical engineer of the iRobot Roomba. So designed the platform chassis and shipped it, and lived in China for half a year getting it into production, and it was fascinating because it was a chance to go from 0 to 1, right? Just blank screen. 2 years later, running assembly lines. And you go through an experience like that, and it's transformative, right? You're never the same after that because you understand what can happen, right? And where most of the world goes through what they think can happen, when you actually see what can happen with the right people, that thought process is to some degree what brought me into the visual effects and the filmmaking world is, with a tiny team, what can happen. Right. And that's, and that led to later on to what we're to Jetset now. But in those early days, it was not lightweight. It was not portable.
It was a huge camera. Like it was, so there was you had, because you had a tracking system, right? So it was an inside out tracking system for the camera.
Yeah. And early on, we understood what really needed to happen. I mean, it was very clear early on that the big killer in all this stuff was getting a good camera solve, understanding where the camera was. And I want to kind of outline because when he says the trouble here, it is, so when I worked on Star Wars, there was a whole department that was match moving. Now you'd think that they were running a match moving software. No, they weren't. They weren't running match moving software. They were running, they would sit there and put a box in the room and try to figure out because we would get camera reports that were not accurate at all. Like, so that it would be like, this is 35 millimeter, whatever. And we're like, that is not a 35 millimeter lens, like that. And so you had to figure out what the lens was. You had to figure out where it was. You had to figure out the distortion. You had to figure out all these things. And they would do it by hand every frame. And what they'd do is they'd find where it moved a lot. They'd set a keyframe, and then they'd go from this to this to this. They'd find the big points, usually the start and the end, and then they would find the big points, and then they'd put them in, and then they'd start frame by frame. And even now, if you look at Star Wars Episode 1, there's little places where Jar Jar's feet are just sliding just a little bit, they're not quite right. And then we finally got software that would do it. So you had Buju and you had Match Mover Pro, but that all, you run it into a process and it would all come out. The big thing that I know that with the big machine, what Eliot built was the ability to do that live. So that inside out tracking meant that you could look at a composite and see what you were doing while you were on set. I mean, that to me was exactly the takeaway. I learned a little bit of the post tracking, and it's sort of fragile. But the key thing is that when you're in a creative process, you want to see what you're doing while you're doing it. I mean, it's a visual process. You actually like to see what you're doing, which seems, a radical concept, but and that's really where I looked at it and said,
okay, the camera tracking, we have to solve this, but I want to solve it interactively. I want to actually see what's going on while we're doing this.
Right.
And, I kind of, what I jokingly termed is, what I wanted is, of course, me knowing nothing about this, was I wanted my own little ILM in a box,
Right.
And that, but so that first, systems were crazy and targets in the ceiling and huge amounts of stuff. And what was exciting over the years is to make it better and a little bit better. And then it was about 5 years ago that I just hit a wall with that original approach. And I reached out to Bill Warner, and who I'd known since I started the company back in Boston. And Bill founded Avid. And so I rented my first office cubicle from Bill back in like 2004. And some years later, after I'd moved out to LA, I hit a wall with this, with the existing approach, big machines, hardware, this kind of stuff. And I reached out and said, there's something here. I don't know how to do this. I need help. And he came on board as our chairman and as our investor. And that started a process where we spent the last few years rethinking production. Like from the concept to, and that's where we ended up with Jetset, which is, it's an iOS virtual production app that's doing all the stuff and more that those crazy carts of equipment did when I hauled them up to your space, back in 2007, but it's in an app.
Right. So give us an overview of the app.
Well, all right, I can turn on a fun little demo because it's always more fun to see what we're doing. But virtual production at its core is just combining live action and CGI. And so what I'm doing here, and this is all running live in our app. And in fact, I'm still in my office. There's no green screen or anything like that. So I have put myself into a 3D environment. There is a little bit of an X-wing going on here. One of the guys built the whole scene out for a project he's doing. And
what is the 3D model in?
The 3D model is actually being rendered inside the phone. And this is a key aspect of it. We originally built the model in Blender. And then the way Jetset is designed is we actually are rendering everything inside the phone.
Now, is that USDZ or is it
USDZ? And later on, I'll show a brief demo of some of the more recent work, which is Gaussian splatting. But since it's a USDZ model, it can be animated. So I can turn on the animation, and after a while, you're going to see the little creature moving back in the background, and the hatch is going to come down, and we're going to start taking off. And we're going to start flying. And since we can have a moving scene, I can be tracking the camera around myself as we go through it. And I'm locked. My origin is locked to myself in the seat. But I can actually move, do a bit of a flying shot as I'm moving around. And so we're using an AI map.
This is not so that people understand it. This is not for the final shot, but this is so that you can, while you're recording. So if you hit record on the phone right now, you're going to record a clean plate, right, of you.
Yeah. And so this is the core of all this is you're trying to see your live action and CGI together in a preview form and capture the tracking data so that you can take it and do more finished work in post-production. And so that's, there's a couple of great things, with this. And instead of a green screen right now, we can use a green screen, but right now this is using an AI mat. So that's why my edges are kind of choppy. But there's a reason for all this. And the reason comes down to, and I'll switch back to my normal framing for a second. The reason comes down to you want to be able to test out what your ideas are in a lightweight manner. And you want the goal of what we're trying to do is build a bit of a unified approach to like the preview, the planning, the onset, data capture, and post-production, all with a kind of a very lightweight tool set. And one of the things that I really noticed when I was looking at this is that in a strange way, because I came from mechanical engineering, I think filmmaking is a lot like mechanical engineering, which is that the predictive tools are not great. It's very hard to tell what you have before you build it. But after you build it, a 3-year-old can tell you what you did wrong. I mean, it's just, right. And so what you want to do is have something you can put together and watch as quickly as possible. And you guys, Island was doing this 40 years ago.
Well, again, when we were, what I was thinking about when you were doing this, when you're doing the X-Wing, what I was thinking about is that we were doing, so I worked, as a lot of people know, I worked in pre-vis for Star Wars Episode 1. And we had the end battle, space battle, pod race. Those are the big three things that we worked on. And the pod race was a big chunk of what we did. And to get what we're trying to do is hack the key is how do I hack together something that the director, George Lucas, can, our job was to get things done very fast so he can make decisions about how it flows, and what does it look like. And we can edit, because what you don't want to do is have a bunch of visual effects that end up on the floor, because that's $100,000 a shot that you're throwing on the floor, $100,000 thrown on the floor every single time you do that. And so what you want to do is figure out how do you do that whole edit before you start shooting. And so the thing is that, but I was, when you were bouncing around, I was remembering Ben Burt. I don't know if you've ever seen the pictures of it. I was trying to find it online, but I can't find any pictures. His son at the time was, I think, 7 or 8 years old, or maybe 10 years old or something, but he was young. And Ben Burt had I think it was a trash can that was sitting upside down. And his son would be, grabbing onto it. And he was Anakin. And he had like a little hat. And he had a green screen that he was using to just kind of pull things out. But it was like he's like going like this. And then Ben would cut him out and like set him inside of, we would give Ben some plates from the pod racer. And he would do this thing. And it was like, and I realized that we have to show this to Ben. So we'll see if we can get Ben to use your app a little bit. But
that'd be great.
I was like, he's going to love this idea of what it took for him to do the previs, or for us to do that previs, where we're taking a human being and throwing them in and understanding, because that made all the difference. Now, in this case, you're able to previs all of those things, but you're getting the clean plate out right from the phone, or a camera, right? You can you can tie this to the camera.
Yeah, and this is one of the things we really, really wanted, and is. We built those big systems that were built around a cine camera, and then, had a tracking device set around it. And at core, everybody wants to shoot, a movie on a real cine camera, right? The phones are getting better, but the glass is still a thing. And so we wanted to put that together. And so we did a project with, we built the technology to do it. And I'll share my screen to show the piece of this. So let's see if I can get this right. There we go. And so we did a project with a compositor up in Canada, and I wanted to show what was possible with our system in a very, very lightweight setup. So this is in his barn in Canada. That is Jetset sitting, and I'll pause these things because it goes kind of quickly. So this is our Jetset camera mounted on a normal DJI RS2 stabilizer and on a Sony FX3. It's basically the same rig they used to shoot the Creator, shooting ProRes RAW. And the phone is so light that it doesn't overload the rig. Just a standard off-the-shelf $599 Ronin rig. And on set, we have the real-time preview, so you can see he built a CG background, which is the kind of this wild factory that we set the project in, and it's doing a real-time comp and blend on set. And so there you have him working through it. And again, what was really fun with this is that he's a compositor. He knows exactly what he needs. He just built the floor. And just hung a few green screens and set the lighting so that he could do it correctly and make it look right. And then there's basically 2 people on set. And so we were able to get this kind of a result off of this. And so this is the, kind of the short film that he put together of just a few shots and that's his wife in a hazmat suit. So she's very understanding. And I wanted to get across, when we talked about what we were trying to do, we both came to the same conclusion of what we wanted to achieve. And I wanted to show what's possible with an incredibly lightweight setup. And we both converged instantly on the, like the look of Alien and Blade Runner and these kind of, late 70s, early 80s things, Star Wars, heavy atmospherics. Like the place is just full of smoke. And people think you can't do that very well with green screen. And I wanted to show, way do you get a 12-bit camera?
Right.
And so we put this project together to show what was possible with this incredibly lightweight setup. And what you can do with the modern cameras. So those 12-bit cameras are incredible. Green screen is a different world with 12 bits.
Right. Yeah, a lot more data to work with.
And in this case, what we're doing is we're capturing the onset data from that cine camera, from the lens data, pulling it into post-production. So with an automated tool set.
How does it handle? Of course, for people who are watching, you have this. Your camera's here, but your phone is up here, right above it.
Yes.
So how does it handle the tracking? How do you manage that between the 2 pieces there?
Oh, that's a great question.
Because there's everything will be different. With the camera in 2 different places. Because we spend a lot of time trying to find the focal plane and trying to make sure that we're tracking right to that center of that focal plane. But you have a camera that's offset. So how does that work?
Okay, this is really fun. This was one of the pieces that made this possible is that we started building the app several years ago, and we knew we needed to get video into the app to be able to calibrate, but we didn't know how. And then a little while ago, a company called Axoon constructed a device called a CMO, and they shipped it maybe a year and a half ago. Mm-hmm. And that takes a HDMI or HDSDI feed from a cine camera and converts it into, an H.264 feed, and it brings it into the iPhone.
You're tracking the actual camera.
Well, so it's close. So then we built this part of it, and what you're seeing is our lens calibration system. And so what you're seeing is it has 2 feeds going into this, and this is also built into the Jetset Cine app. So there's 3 versions of it. There's the free version on the website, which is the base Jetset.
And that actually the free version versus the pro version.
The free version is actually really powerful, and it loads user-generated models. It'll record on the phone, 1080p, records all the tracking data, and it works with our automated post system, which is honestly, in all of this, that may be the biggest part of it that people don't realize till they shoot a show and they're like, this is great, because the auto shot doesn't look pretty. It's just effective at processing shots. So in this case, for the Jetset Cine, it's one of the paid upgrades. It lets us link to the Axoon, and then it's detecting in real time natural features in the scene between the iPhone camera and the Cine camera. We capture an image here. Yeah, we move it over to the side a little bit.
So you're not using it when you actually do the shoot. You're not using it there, but you're using it to calculate the offset between the two, so that it can mathematically triangulate the difference between them.
That's exactly it. We can compute the correct offset, including the angular offsets, which are crazy critical. I mean, you have to be within 1/10 of a degree, otherwise, you're not there. And as well as the entry pupil, or the physical offsets, and the field of view of the Cine lens, and 1 term of distortion. We're not calculating 5 terms yet, but 1 term gets us there in terms of the basic offset, and that's what and the basic field of view, and that's actually the part we need to be able to bootstrap post. And so that's, but I love the question, because that's exactly the first thing is, okay, how do you calibrate?
It's great. And I have one of those Axoons laying around. So I was like, oh, I got one of that. I haven't found a use for it. I bought it to play with it. I played with it. I was like, oh, it works. And then I just set it down somewhere. So
it was the Rosetta Stone in terms of, and we think that
how long does that calibration take?
Like 4 minutes. It take, go boop, 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 capture 10 frames. We do a very basic photogrammetry solve and compute the offsets, push it back to the phone. That's it. No calibration boards, none of that stuff. It's just using the natural features in your scenes. You just turn it around and point at the part of the stage where all this stuff's piled up. Perfect. Shine a light on it.
So then after that, your phone is generating the tracking data. So you're capturing your video, and the phone is, and how do you align that data?
Yes, more good questions. So when we have a digital slate built into Jetset, it's basically a web server, and so you'll typically point and I can share.
So you're using it, so it goes out to an iPad or something like that, or you open up an iPad with a web server, and it's the iPad is talking to the phone, and the phone is setting the slate so that you know when the start frame is on the video.
And when we hit roll on Jetset, it automatically fires a series of black and white QR codes, basically Aruco markers on the digital slate, so that both the Jetset camera and the Cine camera can see those. And in post-production, we just sweep through all the takes and we detect those markers. And each Jetset take has a unique 10-digit hex ID. And that way you can shoot for, I think I calculated out, 5 years straight, and you'll have a 1% chance of the takes, running into each other.
Well, so that's your post tool. So I don't have to figure out what this is in my post tool. You process the footage with the data.
Yes, that's one of the key pieces of all this, is that when we built our earlier systems, we built these big real-time systems, and they got used, 7 years on Once Upon a Time and Pan Am and V, and I mean, we won an Emmy for this stuff back in 2013. And we got to know high-speed episodic production really well, which until you've seen it, it's hard to explain. Once was turning around 250 plus effect shots in less than 2 weeks, from cameras roll to your living room, finished, cut, edited. I mean, it was astounding. And witnessing that, we realized we were we built the front end for that, but not that many places could handle the rate of speed of the post. Zoic figured it out. Stargate, in the big places, ILM, actually not ILM, ImageWorks on Alice, no problem. But the little places, the 6-person groups, which is really, in some ways, what we're aiming for is a small couple persons, half a dozen people effects team. They didn't really have the automation programming tools to basically handle the data flow. And so this time around, what we built is we built the front end, which is Jetset, which is, captures the data and the scan and that kind of stuff. And then we also built AutoShot, which is a fairly ugly looking piece of desktop software, but it takes that data and formats it, does the frame pulls to EXR, et cetera, and then wraps it up into a package and then puts it into Synthesize or Maya or Blender or Unreal. And that, flowing that pipeline all the way through, that's the key. That's how you go fast. And that's, I'll show you a quick, let me pull up one of these things real quick because it's worth
Cinema 40.
Yes. Actually, that was the very first one we did. Very first one we did, including the slightly gnarly Python implementation. Yeah. So when you want to do that, let me know, and I'm all for that. But I'll pull up the Synthesize one because this is actually, in my mind, where we cross the bridge from being this is fun to this is now we're in serious business.
And for our viewers, while he's pulling that up, we will be getting to your questions. Are starting to stack up, so we're going to be getting to your questions here in just a minute.
We're blitzing through at a.
I'm geeking out a little bit with Eliot.
Well, this is great.
My brain is starting to is all tying this all together. I lost track of time. I just looked up. I was like, we've been talking for 21 minutes.
Well, but the key is, in some ways, Alex, this is what I saw when I was in Pixel Core was the opportunity to expand who could make media, right? Because traditionally it's you need a George Lucas or a Cameron or something to do this kind of what I'd say a visual world build. And what I wanted to do is build the piece that let lots of people be able to do this amazing world building kind of work that we all go to the theater or go to. This is the things that we love seeing. These are the big projects. And without this, with this, a small team can tackle it.
And
Without
it's not just green screen, right? It's you're getting a matching plate, so you could be shooting someone walking through a street, and if you want to add other effects to it or anything else around them, it's also you would now have all the tracking data to do that.
That's exactly it. And the phone in real time, it's good tracking, but it's not perfect. In a lot of cases, you're already done with the phone data. But in the cases where you need that, it's not a sub-pixel track. And and for all the viewers who are when you have a visible scene between CGI and live action, the level of precision that is required to make that not wobble is incredible. You have to be actually less than a pixel's worth of error. And real-time systems, for the most part, ours can't. I did the math on it, and you have to be in less than a tenth of a degree of alignment and at some long range, and it's very difficult in stage work. So we built this pipeline to take our real-time data. So we have tracking data and the lens data that we already talked about, but we also have scan data, and that's built into the iPhone. We use the new LiDAR systems, and it gives us a rough scan, but it turns out that's all you need. And so this is the pipeline that we wrote, an automated batch pipeline for Synthesize. So I'll start playing through this to see this, because this to me is where the game changes. So we AutoShot generated a script that we're just going to run on this, and this is a Synthesize Sizzle script. And in here, we've already brought in this red mesh here is the rough onset mesh, from the iPhone that we captured. And we captured we did the cinema lens calibration, so that's correctly offset. And we have the real-time tracking data. And all these three pieces of data let us give a springboard to do post-tracking. Because traditionally with post-tracking, you don't have any data from set. It's exactly what you described. And inherent in the math is you don't know scale, position, all this kind of stuff. So that's our springboard. So once we're using an AI generation rotomat here. So and this is automatically generated because you don't want to put tracking points on the actor because it'll throw off your solve. So we use AI to find a rotomat. That's automatic. And then we're going to run
it just gets through the actor automatically. It doesn't. You don't have to think about it. Yeah.
And here we're telling Synthesize to automatically walk through. This is actually a script that Matt Merkovich, who's a Synthesize god, worked up, which is it's telling Synthesize to work through and generate frames in a small, medium, and large level. So this is the set of all the points that we found. But right now, those points are just in 2D space. They don't understand 3D space yet. And what we're doing here is we're picking out several of these points, and we're going to do a track drop onto mesh. And bam, by projecting through our tracked camera, through those detected points onto the 3D mesh, now we have survey data. And survey data is like the magic elixir. Because normally on a big stage, you've seen it. You've got the 4 people walking around with a theodolite or a surveying tool, taking laser shots of pieces all over so they can feed it in. Once we have that 3D data, then and we're going to go to the start of the shot, get a few more points so that the solver knows what to do in the very beginning. And we'll do the same tracked point on this. Then we can tell the solver, go ahead and solve using those as reference. And at that point, we can hit go, we solve, and boom, we've already done our first solve in some number of seconds. And we still have about a 5-pixel error here. So we just do a quick, simple, removal of kind of the most egregious offenders of the tracking, tell it to switch to refine, tell it to go. And we're at a pixel, do another refinement step. And the key thing here is you'll notice that the camera has not moved more than a centimeter in this resolve. We're still exactly aligned with that original scan. We're still aligned with the original data on the set. And so we've gone through all this, and we're going to, we can go and now we can add the distortion solving and use their new distortion model. And with this process, I think we can actually get anamorphics. We haven't gone through that yet, but it should work because we have the physical data.
For folks that are watching there, anamorphic is you have a lens that squeezes a wide, typically a 235 or wider, onto a standard piece of film. And so you have this lens that distorts it in, and then when it goes back to the theater, it distorts it back out again to get the widescreen. And it is brutal. It's brutal to track because now you're not. It's not like straight in, straight out. It's like this weird twist in and twist out that makes it very, very hard to shoot well.
But to
track well not shoot, but to track well and add effects. Let's jump into some questions because we've got a couple of them stacking up. Let's go to the first
good.
Rian Smith is up first from Trinidad in the West Indies. Can this be done with Android, and how high level does the phone need to be to capture this?
Sure. Right now, we're only on iOS just because of some of the tech stack that we use on the iPhones. But I would view it less as like switching to Apple rather than just get an iPhone to stick on top of your camera. Just treat the iPhone as a piece of production gear.
It's an appliance.
It's just an appliance.
Yeah, and it's the LiDAR is part of it, right? I mean, you need
the LiDAR is a key part of it. That was, and in fact, this started.
The irony, of course, is that Google was first.
Oh, I saw it, and I remember seeing that. And we try all the different trackers as they come out, and I tried the first iPhone tracking, and it wasn't quite there. And it was actually this phone actually was the iPhone 11 Pro. It still didn't have LiDAR, but I was testing it with on our stage and went, this thing's tracking. Like this is it as good as our custom built machined military gyro overhead marker thing? But it's close. And I went, that's it, man. We're jumping.
Absolutely. Next question.
It's actually from me. I was wondering about the camera system. When you talked about a Cine camera matched with an iPhone, what kind of cameras were you running? And what was the motion control rig that got that geometry to move in relation to the background?
So when we're tracking, so the iPhone actually is detecting the motion. There's some software designed into iPhones that we've piggybacked on top of, and we build an app to make use of it. But the underlying technology inside Apple is called ARKit, and that solves where the phone is in 3 dimensions of space. And so we were building on top of that. That's what Jetset is using to track. But in addition, we actually are solving the optical offsets to the Cine camera, and that's the part where now we can get some magic in it. And so as you move the iPhone around, we're computing where you are in 3D space down to about an accuracy of around a centimeter. And that turns out to be actually pretty close to how accurate motion control is. And then we can take that and further refine it.
What tier or level of Cine camera is required to be able to have it react to that?
It actually works with almost anything. We need a clean HDMI or HDSTI feed out of the camera that doesn't have overlays. The overlays will mess up the calibration process. And the feed out of the camera needs to be the full width of the sensor. So if it's a cropped feed or something, which you don't see that these days. Some in the really early mirrorless DSLRs had kind of a sort of a broken HDMI feed, and that won't work. But almost anything modern, it'll work fine. We've worked with everything from an Alexa 35 down to we've got a Blackmagic test rig over here. We've got Canon's whatevers and Nikon's any mirrorless, almost any modern digital camera will work with an HDMI or HDSTI feed.
And is the camera itself on a motion control arm of some kind to allow?
This is what's fun. I'm holding this handheld. Right, so it's computing. So let me flip this on.
And you don't even need. You have it on an Osmo, but you don't even need that, right? You can just pick up the Osmo. You can just grab the camera and handhold it.
And actually, we have a bunch of people that do fun things like where they run around and you get kind of this sort of cops level, handheld motion tracking, and it's it's a little bit revelatory because it means that it doesn't matter what your camera move. We can largely track it almost no matter what you're doing. And it brings up some wild, things we're looking at doing. We're looking at tracking, props on set. Why you just tape an iPhone onto the sword someone's wheeling around, and we can track it in 3D space, which is a lot easier than getting a whole OptiTrack rig. And the big rigs are more accurate, but for a whole category of problems, you can get close with the iPhone and then lock it in with a little bit of post work.
Next question.
Next question comes from Rion Smith again in Trinidad, West Indies. Are there any integrations for spatial 3D 180 360 videos and things like Meta and Apple headsets?
Oh, this is an excellent question. So when we were doing our post-tracking refinement, and this just cropped up, one of the videos came up on the internet a couple days ago where they were using an Insta360 where they mounted it on top of a camera, took the footage and ran it through a Synthesize. And then, with tracking, especially the wider the view you have, the better. Basically, a spherical is the best of all because then you have points in all directions and you can back out the math. And I looked at that and said, that is genius. We're going to be doing some work with that to where already AutoShot is a tool that is used to combine data feeds from a number of sources. And it's right now we automate our EXR frame pulls, from the camera original footage, raw or log, et cetera, to basically a standardized form that we packetize and put into, EXR files and put into, Blender, et cetera. But now with that new device, with a very inexpensive 360 image camera that runs at 24 frames a second, we're going to be doing the experiments where we do the same, automatic firing of image sequences so we can do the same frame pulls, and then we can pull in that data into Synthesize along with our main solve. And I think that is going to be near magical because you run into problems when you're trying to post-track through the main camera that are just inherent. If you're racked in on a 70 millimeter lens, the whole background's out of focus. It's just very difficult to get data. Or if you happen to be doing shots with stunt people that take running leaps with the camera off of crash pads, the background blurs like nothing going. Whereas adding a 360 camera into that should give us some really great additional data. So the answer is yes, we're looking at it.
Well, and to go back to that, so that means, just to make sure I got this right. You have a camera. Let's say you have an Alexa, LF or whatever, and you've got this nice short depth of field. But you're not trying to track that data. The phone is tracking something that has a much deeper depth of field. So you have a phone on top that's generating tracking data for something that would be typically very hard to track because it's got short depth of field. Is that?
Yeah, and we use the phone is doing the real time tracking, full stop. And then when we pull the package into Synthesize, then we are starting to track through the original camera frames, right. and that because you need that to get the final subpixel lock. The problem comes is that it's very easy to have a camera shot with the main camera that is very, very difficult to track. Where then you have to do traditional modes where you're manually matching things through frames. Yep. And this is something we're going to be experimenting with because I see a way of doing this where we can stack data together. With each source of data, they have strengths and weaknesses. And I think we're going to be able to do some automatic work in this. But this is very recent, so it's a little bit forward projection, but it should be fun.
Awesome. Next question.
Jason Corella in Miami says, is there any way to incorporate this technology into live production with virtual sets?
That is it's a great question. And we've done some initial work with that. And I'll bring that up where we have a live feed coming out of Jetset where we can bring it over into Unreal. And I'll bring up an example of one of the shots where we worked with that. So let me get our Genlock shot. And the trick, of course, is that by default, traditionally the way you get a very high degree of accuracy in post-production or in real-time work is you have what's called a Genlocked feed. And that is an artifact of a long time ago, but it's an analog sync signal that you feed into all your hardware to get it to all fire at the same time. The phone has no such thing, but we were able to build something that is basically what we're calling a bit of software Genlock. And I'll go back to that one because it's worth understanding this. There we go. Let me pull up my full screen. There we go. And so this is live data coming in to Unreal from Jetset, and I'll just I'll hit start and stop so you can see it. And hopefully this is coming through coming through Zoom.
Yep.
But it's pretty well synchronized. It's pretty well synchronized up, and we wanted to show that the data is good, and it's not a subpixel lock. The original data is not a subpixel lock. I think it'll work well for some applications. Ultimately, we're not really targeted at a broadcast application. I think there are other tools that are probably a better fit for that. Our heavy focus on our workflow is really dramatically pipelining storytelling. Episodic, commercial, feature film, like really making it possible for small groups to do great visual storytelling, and with a heavy focus in that area. So if you're transmitting the Olympics, there's probably some better tools out there.
Next question.
Rian Smith back from Trinidad with, is this available to be done live streamed? Example, putting someone into a football field during a live sport.
And this probably comes back to that. It's probably not a live application. It's really more of a pre-vis application and a data gathering.
Yeah, we have a real-time preview system because it's very useful to be able to look at your lighting on set and to be able to look at things and then synchronization. But it's not really tuned as a broadcast application.
Next question.
Bobby Rafferty in Central Florida. Up next, can you speak more about the workflow of building the scene in USDZ?
That's a great one. So we have a pipeline that works from almost every 3D application that you would typically be using. We have a pipeline for Blender and Unreal and Maya and Cinema 4D. And because the commonality with all of these applications is they can all write out to a format called USD. And USD Pixar created it years ago as a 3D exchange file format. And the iPhone uses it as its standard, a version of that, USDZ, as its standard input.
And USDZ is just simply the USD zipped.
Yeah.
That's the Z, yeah.
And so one of the things that we did very, very differently than anyone else that I've seen in virtual production is we centered it around the iPhone. We centered. So the way our process works is you might build a big scene in Blender or Unreal or something. That scene is too big to run in the phone. So you'll write out a subset, a small layer of that is you're going to use for blocking geometry to know where you are in the scene. And that can be compressed down to fit into a much smaller package. We send that package over to the phone. You shoot with this. Using a concept that we built called scene locators, which is just a position in the scene that you can kind of snap to very quickly. In the example of the X-Wing, I put my scene locator in the pilot's seat so that the app is centered around that. Then when you shoot your data, we send that data back into your original app. So instead of requiring a parallel pipeline, which is traditionally the case in a lot of virtual production, you'll have your main scene in Maya or Blender, and then you'll have an Unreal setup. If you're running Unreal as your primary pipeline, great, we work with that. But if you're running with Blender as your primary pipeline, we work with that as well. And that way you stay with a single data source, which is your main 3D app, and we just use the USD largely as a proxy because we can't have as much texture resolution in that. Now, I say all that, and we actually have some very, very recent work where we are now rendering Gaussian splats in the phone, and those are a game changer in terms of what is possible on mobile equipment.
And explain a Gaussian splat for our viewers.
Absolutely. A Gaussian splat is, and actually, let me, I'll pull up an image of this while we're doing this. What it is in traditional photogrammetry, what you do is you'll take 700, 800 shots of something, and you'll run it through a program, and you'll extract basically the polygons and the surface material from that. And with Gaussian splats, it's a very different approach. You can still take that 700 or 800 images of something, but instead of trying to extract polygons from it, you are extracting the lighting of it. And I will share my screen to show. This is a quick tutorial that we just did because we're just now releasing this workflow. And what this is this is being rendered inside a phone. This is a Gaussian splat of a coffee shop, actually in Beijing somewhere, done by one of our collaborators. But the key thing is that the reflections and the lighting are changing in real time as we move. The couch, there is actual shine, there is reflections moving in the sofa, and that is a unique characteristic of Gaussian splats that you cannot get with photogrammetry. Photogrammetry, basically
And to build a Gaussian splat, you're just wandering around with the phone, right? I mean, it's...
Yeah, there are two ways of doing it. One, you wander around with a, iPhone or et cetera. You shoot it's the same original source as you have with photogrammetry. You shoot a bunch of images. But then the compression and the training of it gives you this compact file we can render in the phone, and it looks remarkable. But you can also do this with 3D, and this is one of the things that we're also interested in. If you have this big, crazy, scene that's in Blender or Maya or Unreal, you could actually pick an area, generate Gaussian splats around that area, and load that into the phone, and then you have captured the lighting and the reflections of that original CG scene. So we think the splats are going to be, it's a strange name, Gaussian splats, but whatever. The technology is fantastic, and it changes the game in terms of what we can get. We're always trying to figure out, the phone is such a wonderful, lightweight tool for sketching in space and time, right? You pull it out of your pocket, and it's doing the real deal. It's tracking, it's calculating. And now you can actually, this is a segue a little bit, but one of the reasons we made the base version of Jetset really powerful, I mean, it's got our full 3D scene loader. It doesn't do the Gaussian splats, that's in the Pro and the Cine version, but the free version will do, the X-Wing stuff, the real-time camera tracking, et cetera. We want people to start planning their movies with this kind of tool, where you shoot it before you actually go and shoot it, right? You actually plan in your living room in your bunny slippers, your shots, find out the things that work. And then only then, using the Ben Bird and his kids on the garbage can analysis,
right?
Then you take that information and go into production.
Yeah. And I think that's the really interesting thing. And when one thing I was thinking about is like Peter Jackson in the original Fellowship of the Ring. There was this shot where he had all the previs, or actually the animations of the fight with the
cave troll. Oh yeah.
And it seems like that could be, because you would be able to have that entire scene in there animated, doing its thing, and you could be doing that camera motion where you're looking at this and I'm looking over here and I'm pulling over, and then take what you created and simply dump it out, right?
Well, and that's exactly it. We can handle animated characters, simplified versions of them inside the app. And we actually have a couple of videos coming out with...
What's the maximum poly count?
The poly count actually can get decently high. We've run, I think 500,000 or 1 million polygons pretty easily in the app without too much difficulty. You have to be a little careful with animated characters, how you export them, because if you want to have them as like rigid body elements, instead of USD will by default export an animated vertex cache, which is a lot for a phone. But if you keep the resolution down to controllable levels, or split them up into rigid parts, which we build a Blender add-on to do that, then yeah, you can actually have multi-minute takes of the animated characters running around in the phone. And then you're shooting with an animated character reference and interacting with the live action person. And we can actually embed audio from the animated character in the Jetset. So they're doing their lines correctly in sync and the actor can hear them. And again, this is,
and then you're taking that camera data and you're just simply dumping that camera data to Maya, Cinema 4D, Houdini, whatever. You're dumping that out, and you're able to, just hit render. I mean, essentially, right? In that case, there's not a lot of cleanup because it's just positional data.
Yeah, I think people are going to be shocked by what is possible. I think repeatedly, people are so accustomed to thinking of virtual production as, a big circus, right? And I was part of that circus, right? Big racks of equipment, you saw the circus. And now the core of it is just, how do I see how the live action and virtual worlds are going to intersect? And that's a phone now. And there are reasons to use bigger things in certain cases, but boy, you can do a lot with the phone.
Yeah, 100%. Next question.
Kyle Hammond in Chicago says, what's the story behind the elephant in the C-130?
Oh, the story behind the elephant in the C-130. Oh, there's a specific answer. Bill Warner had done a project over at a high school in Massachusetts, and they had a story of, they were having to airlift an elephant, and I don't remember all the details of it, but it involved a C-130, and so they built a digital C-130 with an elephant in it in some cases, and they set it up so that. And this is one of the exciting things of it, is they brought it into a high school. Our goal with Jetset is we want to make it easy. Like I built one of the versions of the systems that were hard, like Prevision and Halide are previous versions. They're hard to use and it's not fun. I wanted to build the easy version to use, which is Jetset. And it means that we give it to a bunch of high schoolers and give them a rudimentary set of instructions. And they were doing track shots, going up, they figured out how to match the steps of the C-130 up to the steps of their auditorium. So they could do these running shots up into the C-130. And it was just fantastic to watch that process. So that's what that project was from.
And how much data how much 3D data? So like one of the things that I've done a little bit playing around with visual effects is that I'll take Polycam out, and especially something that's a little bit organic or something that's got lots of detail to it. And I just swing my phone around and I gather all this 3D data. And then I can track that back into, I can have a scene and track it, and I can have water or little things running down it. And it's all, I'm just using that as the collision detection, the collision. Is that the kind of data you can grab with the phone?
Yeah. We have a built-in scanning system inside Jetset that only does geo. We don't grab textures, and
that's fine because I don't need the textures.
What we found is that, and Polycam's actually, in truth, better at capturing an Atoll environment. Mm-hmm. What the Jetset one is a bootstrap. You set your tracking origin and set your scene locator, do a quick 15-second scan around it, and you've grabbed the surrounding 5 meters, 10 meters of surface space. Your orientation around that. And what we've added into AutoShot is the ability to take an external scan and drop that in along with the Jetset data. So the Jetset data, the scan is perfectly aligned with the tracking data. That's its win. But the resolution is medium, and there's all sorts of cases where you would want much more complete scan, whether from Polycam or from a LiDAR, right? From a big LiDAR, from a BLK 360.
So I have a BLK 360 right here. The question is that are you taking E57s, or are you taking what do you take in from the BLK 360 specifically?
In AutoShot, we have a line where you can read in an external device, and it's just a PLY file. We want to mesh it, and you get a PLY, put it in, and then it'll drop that PLY file into. And this is key. You want to have the same origin. Have all of your origins be the same of your scans, etc. But then when we pull that file, we drop it into Synthesize. We drop in the PLY file correctly aligned. So Jetset is working with, as we said, called scene locators. Because if you have a huge world, if you're shooting throughout a digital city, your origins are going to be all over the place. Mm-hmm. And so each place where you would put an origin, we put what's called a scene locator. All it is a named 3D null, scene loc underscore, front door or side door or something like that, or, top turret or whatever. And then in the app, we parse the USD file. We look for those specially named nulls, and then we snap that null.
And am I manually building those nulls, or is it automatically going? That's a point that I can easily identify.
In the original 3D, in your original Unreal thing, you're just building the nulls. You just drop down it wherever you think you're going to want to shoot. That's where you put a scene locator. Just drop an empty, and then in Jetset they automatically show up, and you can scroll through them and you can pick them. So what I can do here, let me kind of show this as a quick example, because it's more fun to show the use case. Let me switch to my virtual camera. Okay, so over on my right, you can see my UI. I'm originally in the pilot seat. And what I'm going to switch to is, say, a balcony view, because now I'm looking over the balcony of the scene, and I can look up, and there's the X-wing, taking off and getting ready to fly, and then we can watch and see it pan by, and again, try this out. We can look at the same view from, say, the ground takeoff. Whoops, let me find the ground takeoff. There we go. And now we're on the ground, and all these things is just a named 3D null that we placed in the original 3D scene. Mm-hmm. That when we export it, we just parse the list and give you a list. And so then we can actually have these nice viewpoints of these nice shooting locations that we basically picked out. You just pick out your shooting locations, and then you can work with them. And it's a very natural way of working. Oops, sorry, just turned off my video. I'll switch back to my.
And what's funny is this is about the resolution that we did episode 1's pre-vis in.
Well,
I was like, this looks familiar. That's about what we did.
It was actually funny at NAV. We had a couple of people that had worked in Mandalorian, come by, and they were accustomed to seeing very large, setups to do anything like this. And I think that the sight of it running in a phone was kind of a surprise. Yeah. But it's that's it. Like you want to be able to, in a very lightweight manner, bounce around to the different parts of your scene, by scrolling and doing a pick. And then where I'm going with the scan data is that choice, that scan where you map. In post-production, we automatically bring that back into Synthesize. So you do your refinement solve, you do all these sorts of things, and that camera stays put. That original on-set choice of I'm located in this part, looking at this part of the scene, is maintained through the entire post-pipeline data chain, all the way through tracking refinement. So you track your refined camera and it goes boop, and it goes back into your original scene, and the refined shot is one-to-one with what you did on set. All the creative decisions you made on set are carefully maintained throughout the entire data chain of transforms and matrices and all the stuff we do, so that we're just trying to remove surprises in post-production. Yeah. Right? Surprises are expensive.
Yeah. 100%. Next question.
Rian Smith, Trinidad, West Indies, is back. Sorry for reiterating. Is there any use cases you're seeing for the Apple Vision Pro and Meta headsets?
I think it's coming back to that. I think it was just like we talked about a little about spherical, but I think that this data is going to be very valuable as you start to it's not so much in when we're starting to build these things. It'll be really interesting to see what the next version of Final Cut does, what it looks like, what it's going to use as far as the headsets go. But I think that obviously the tracking data becomes even more important with spatial.
The spatial stuff is wild, and I have a Vision Pro, and the tracking quality is incredible. I mean, the phone is amazing. It has limitations because it's a single camera. The Vision has like 12, but one of the things that I have never seen, and I expect to see it at some point, is the larger the fraction of your onset that becomes virtual, the harder it is for everybody to see what's going on. And one way of solving that is the big LED walls. I mean, they're great, but it's $40,000 a day just to rent the space, and then you've got a brain bar and all the costs. Or if it's already in 3D, you could put on a helmet and walk around in your 3D space and basically scout your digital location very easily. And I think that's going to, you can already do it like looking through the phone, but ultimately the phone is really good as a camera. It's not good as a walk around and look around the world and get a sense thing.
Yeah, we even one of the things that we tested. This is with the old Android phones that were doing LiDAR. So the very early ones. Was building virtual museums. So we would scan all these sculptures and put all the stuff together. Now we had little Zimbabwean, Shona sculpture, and then we would put them on big pedestals where they're 8 feet high, and you could walk through them. And now what we were doing in that case was the outside in. I happened to have an OptiTrack at the time, so we put points on your Samsung Gear. We're able to and pop the phone on and do outside in, or we'd be able to do it with the phone with the LiDAR. And we were, it was like, I felt like there's going to be a lot of places that just rent open spaces. Like here's a big 30 by, like at a mall right now, you go there and just rent out a space that's 30 by 30 that just doesn't have anything in front of you. And you can just walk around something and go see somewhere else.
Yeah. It's a remarkable technology.
Yeah. Next question.
Douglas Carmichael, what iPhone model do you need for Jetset?
We basically hands down recommend the newest.
Getting better.
I test with a 12 Pro Max, but it gets warm. It gets toasty really quickly. So in general, what we recommend is, the newest. The 15 Pro Max, it was a jump ahead of the 14, and I'd expect the 16 to be a jump ahead of the 15. Especially there's pieces of it. Get the Pro versions because the LiDAR is very key on this, and the data output on the 15 Pro Max is a USB-C port, and so you can actually run a direct data connection when you're pulling takes off of that, which starts to matter when you have gigabytes of takes on this.
And the Axon works with that one as well, right?
Yeah, it can work with both Lightning and a USB connector. New is good.
Next question.
Eduardo Augustine in Panama City. Furthermore, if you can do the tracking, the scene would this work for creating live graphics in a football field, such as stats, names, tracking a player? I understand this is pre-vis, but can this be tested in lab, first down line, and other graphics generating things like that?
So we send a real-time tracking data protocol out, and we have two of them that we send out. One of them is LowNet 2, and that's the one we usually use when we're sending to Unreal. And one of them is FreeD, which is a standard tracking protocol. And we've experimented a little bit. So we've certainly brought in data into Live Effects, which is a real-time, typically used on sets, et cetera. And of course, we have our Unreal pipeline. It's pretty well developed. And so if you wanted to bring live data into Unreal, we can certainly do it. And it works. It's just sort of different products are tuned for different cases.
Right. Next question.
Dave Coffin in Vancouver, BC. 3D Null survey data, photogrammetry. There's a lot of jargon to learn here. Is there a source to start with?
Oh, this is a good one. So we have certainly the Lightcraft Pro site has the tutorials that I've done for this particular piece, and those are sort of the soup to nuts of our intro to Blender, our intro to Unreal, has basically our round trip workflow from Unreal or Blender all the way into the app, bringing it around it and back. And if you go through one of those, you'll really get a sense of how it works. And that only takes something over, it's about a half hour, 45-minute tutorial. And that's a fast trip through that. There's a lot of different approaches you can look at it. And Alex, I'm actually curious, I'm working on our little corner of it, which is the tight loop between a 3D application and tracking and bringing it back to the 3D application, then post-compositing. That's the part that I'm very much focused on. Mm-hmm. But it's an excellent question as to the wider world of learning this stuff. I'm just curious what your thoughts are these days.
If only there was a show that would answer your questions every day, 7 days a week. I mean, that's what you need, 7 days a week. I mean,
yeah.
But we wanted to have them to start at the same time every day, let's say 7 in the morning, so you can get it done in the morning, go to work. And you could just ask questions like, what is a 3D null? Or what is survey data? Or what is photogrammetry? And then there might be people who would answer that question, especially on Tuesdays, because it's oftentimes we have a couple more people with graphics backgrounds. So, but I know a couple of those things a little bit. So anyway, but maybe maybe Eliot will show up every once in a while.
I was today
on
years
Tuesdays.
old when I learned the term Gaussian splats.
Gaussian splats. Exactly. we should talk about that. What were they for? They were FF. They something similar to Gaussian splats. Was it the F?
Just the idea, like looking at a picture and determining the lighting by looking at reflections. I mean, to be able to codify this is amazing.
Yeah. No, absolutely,
it's wild, and it's the paper just came out in 2023, and the first few implementations and. But the real radical thing about it is the way it can capture light and the way you can render it on a mobile device. Like those are the huge game-changing aspects of that.
Yeah. Eliot, thank you so much for jumping on.
It's been great. It's been
really,
great.
really, really great hour. Great hanging out with you again. And I'm really excited to see it. I'm going to start now. Now I got our head all around it. We'll do some stuff. So
this will be fun.
Yeah.
In many ways, I think it's closes the circle that you kicked off many years ago of enabling people to do this, and we're just working on one part of that to smooth the pipe.
Well, that was always the intention of that and this. Thank you, and thank you to the incredible team that makes this show possible every single day. There's a small village that gets this all, that preps people, plans this, shoots and cuts the show, develops for the show. All of those things are complicated, and it takes a huge team to do it. We really appreciate your contribution. Thanks to the producers for all these great questions, both in the first hour and the second hour, and thank you to the panelists for the first hour and the second hour of answering those questions and being part of that conversation. Now, if we had done this, the Tlaloc traversal is if we had gone door to door and answered these questions, we would have traveled 79,000 miles today. That's 128,000 kilometers, and that is 629 million bananas for scale. All right, let's go ahead and jump into After Hours. Oh, that's awesome. I think I have my head fully around it, Eliot. So have you shown this to Stu?
Oh, Mashwitz. I'd love to show him that. I mean, he's another one of my jumping off points. I have my well-worn copy of the DVD Rebels Guide and have been hammering through, one of the things that we just hammered through is I'm like, we have to solve color. So we do go and we do our own frame pulls, right? Because I want to solve that and do the math where we're doing it, and convert everything to an ACES CG XR. And so we're going through all the SDKs and go to from log and all these kinds of stuff. But yeah, then it turns out almost every visual effect shot has the same beginning point, like track, frame pull, extract, package.